Good day, everyone, and thank you for joining us today. My name is Sabrina Devone, and I will be the moderator for our presentation. I am a member of FLUOR'S Office of Technology, which focuses on using science and innovative engineering technology to build a better world. Our engineers, designers, and experts, our people, are at the core of our success. Today's webinar is titled Transforming Capital Project Execution with Lean and Integrated Project Delivery. Lean thinking and management has developed as an alternative to traditional ways of managing projects and operations. In the last 30 years, the construction industry has made big strides in adapting lean product development and manufacturing practices to construction. The Construction Industry Institute Final Report 341 on Integrated Industrial Project Delivery provides fresh motivation for us to consider applying lean holistically for the purpose of achieving superior project outcomes. Our subject matter experts today will discuss the motivation for applying lean methods in integrated project delivery, define the paradigm shift, and describe the characteristics of lean and IPD with real examples. They'll end on a note of optimism by providing evidence of his success from FLUOR'S portfolio of projects and hope for a future full of exciting possibilities. With us today is Jayne Nichols. Based in FLUOR'S Calgary office, Jayne has over 24 years of energy and renewable energy project experience in engineering, construction, and quality. She first used Lean as an engineering department manager and quickly became aware of its transformative power. Jayne decided to dedicate her time to propagating Lean principles, and since then has coached dozens of FLUOR teams in implementing Lean methods in their design and construction. On a personal note, Jayne is from Eastern Canada and loves to spend time at the Atlantic Ocean with her husband and 3 kids. Joining Jayne is Anand Nicodemus. Anand is a Lean Sensei at FLUOR, and teaching Lean became his life's mission after he successfully led a deployment in 1994 as the general manager of a technology company. With Lean, Anand was able to double the revenue in a market that was shrinking by half year over year. Since then, he has taught lean thinking and management in over 80 organizations across multiple industries in 12 countries and helped them improve strategy and operational performance. Also, on a personal note, Anand was a national level chess player and is a keen enthusiast of aviation as well as both human and organizational psychology. Before we start our presentation, in support of FLUOR'S very strong safety-driven culture, it is customary for us to start our meetings with a brief safety topic. Anand, please unmute your line to share the safety topic with us.
Thank you, Sabrina, for your wonderful introduction. Lean is more often associated with efficiency improvement. And due to this, many are unaware that safety is a big goal in lean design and construction. In this application that you see in front of you, home office engineering worked with a fabricator to increase work at grade, while also improving speed and productivity. Panels are outfitted at grade as much as possible, and this is enabled by optimally sizing the pancakes and panels that make up the module to improve safety. Lean techniques were used to explore trade-offs and multiple options in order to improve the quantum of work at grade by 10% to 30%. It's interesting to note that trade unions in Denmark endorse the use of Lean as an approach to minimizing safety incidents and improving morale. Our session today starts with focus on the needs of clients and proceeds to contemplate a new way to look at waste within capital projects. We dwell briefly on the paradigm shift and characteristics of Lean and IPD execution, and provide a compelling case for adoption of Lean. We propose, finally, a holistic approach to the problem. The Lean journey starts with a simple question: what does the client or owner value? This is a question that can be asked for the project as a whole or in the context of granular design and construction activities. One thing that owners value these days, which we are all familiar with, is project completion on an ambitious timeline, sometimes referred to as a gold medal schedule. Additionally, owners consciously aim for a cost much lower than the price offered by the market. The reason for this will become apparent as we delve a little deeper into this topic. However, in response to advice from several independent consulting firms who are providing thought leadership on the topic of capital projects, owners are wanting to be competitive in their segment. They set targets which can be termed capital effectiveness targets or competitive bets. These targets can be in operations, maintenance, or even distribution of the product, but mainly achieved in the design and engineering aspect, as you would all recognize. Let us look at some examples of capital effectiveness targets. Under budget, complete on or ahead of schedule, yet 30% more loading in the solvent. Reduce power consumed in vapor compression by 12%. Goals such as these allow owners to be competitive, in addition to the goals more familiar to all of us. What then is the source of these trifold benefits that owners see? Undoubtedly, the source of all the benefit lies in the design and engineering of the facility or plant. In the illustration adapted from the work of Dr. Glenn Ballard, director of the Project Production Laboratory at the University of Berkeley, if we were to consider the cost of construction to be a unit of 1, which equates to, say, 1 billion, to keep our math easy, then relative to this, the cost of design and engineering will be 0.1 or 100 million. The cost of maintenance and operations over the life of the asset may be 4.3 billion, and provision of services may be as much as 42 billion. On examining the contribution of various aspects of a plant to the lifetime cost of the asset, the cost of design and engineering is minuscule, but has the largest bearing on the overall cost and profitability of the plant. I say profitability of the plant because the revenue generated by the plant should exceed the sum of the costs shown in this picture. Whilst this makes us proud as engineers, it raises another interesting question. How can we leverage more than we do presently the relatively small effort within the design phase to greater benefit of a project? We can, if we can reframe the opportunity. Visualize, if you will, a large hospital in Canada. A busy surgery experiencing a severe backlog in a specialty that sees patients coming from all parts of the province. It's a crisis, undoubtedly. In this real story of my client, the CEO of the hospital and an eminent surgeon himself considered all the familiar options to overcome the crisis. A section of his leadership urged him to increase surgical space, and others thought it was a paucity of surgeons. The surgeon CEO saw things differently. In quiet observation and contemplation of the surgeons at work, he saw motion, excessive motion, the movement of hands and feet that consumed the time of surgeons. By tackling the waste of motion, the hospital now is conducting 30% more surgeries with the same capacity. Reframing the opportunity transformed their surgical operations. Do you think we have the same opportunity in our industry? Jayne will now enumerate some of these ways.
Thank you, Anand. There is significant waste in our industry, as pointed out by the Construction Industry Institute and the Lean Construction Institute. We have all witnessed and experienced waste on construction sites, things like welders traveling across the site to pick up weld rods, or a hydro-test crew waiting for witnessing of a test. But the studies establish the magnitude of the waste. However, can we reframe this opportunity? Can we, like the surgeon CEO of the Canadian hospital, dig deeper and systemically prevent this needless waste on capital projects? We have come to realize that within the all-important but relatively minuscule design and engineering phase, up to 50% of a designer or engineer's time on a project can be consumed in backtracking. This is often seen in concurrent engineering as multiple changes that follow when one discipline makes a change to a design as they are progressing through the project. 20% of an engineer's time can be lost for every additional subsystem they are working on in parallel. An example of this is when the engineer has to work on a nitrogen module and a wastewater treatment plant development at the same time. They're switching between two different contexts. 50% of an engineer's productivity may be eroded when working on more than one task. An example of this could be when multitasking on two conflicting priorities, like reviewing a data sheet and working on a process simulation at the same time. Therefore, how does lean design and construction address this problem? It is interesting to explore the application of a variety of lean methods that come together holistically to prevent the big and significant loss of productivity. However, let's consider two things. What is the paradigm shift in lean design and construction, and what are some of its key characteristics? The first aspect of this paradigm shift is known as target value design. The key difference in this approach is that cost is a target through the front end and detailed design engineering phases. The execution teams are focused on design objects such as vessels, pipes, air handling units, compressors, and splitters, instead of document exchanges and updates. And lastly, the design is done incrementally in smaller pieces with a multidisciplinary team so as to prevent context switching. The second aspect of this paradigm shift is a brilliant development over the last 25 years by Glenn Ballard, who adapted lean manufacturing methods and techniques to planning and control of site construction activity. And this is called the last planner system. The key difference in this system is that the trade foremen, referred to as the last planners, are involved in planning their work. Not only are they involved in planning their work, this system works best with their early engagement alongside designers and engineers. The last aspect is broadly called integrated project delivery. IPD originated in lean relational contracting and aims to create a project community, united by a single contract signed by the client, prime contractor, engineer, and all key builders. They are also united in purpose by one set of goals they establish collaboratively. They have collective responsibility for meeting goals and share equitably in profits, cost saving, and contingency savings. On to you, Anand, to discuss the characteristics of working this way.
Thank you, Jayne. With Jayne having described the paradigm shift, let's review some important characteristics of lean execution. Lean design is primarily characterized by collaborative working. For example, what happens when electrical engineers start with the electrical load list? They're likely to miss a number of power consumers. It's hard to determine if a list is complete, is it not? In this example, you see mechanical, process, electrical, reviewing functionality, collaboratively working in the design space. They use a lean technique to spotlight unit, area, and facility loads through a structured discussion. If a power consumer is missing or unknown, they use other lean techniques such as 5 whys and 5 hows to determine a path to estimating them. The 5 whys is a root cause analysis technique that you're all probably familiar with. And the 5 hows is a technique to generate multiple alternatives to determine the power load of which one can be applied. Thus, surprises are prevented and potential impact on motor controls centers and substations avoided. Lean design and construction is also characterized by integration. Integration refers to the way in which work methods and information systems bring different parties together. Let's revisit the earlier safety topic in which more work was moved to grade. In this example, FLUOR and FABRICATOR are working in the 3D model together collaboratively to determine panel volumes, pancake volumes, and splice points. They conducted their design operations in a co-design fashion to complete 152 modules in a few short weeks. This integration provides for a robust design that suffers minimal backtracking that Jayne referred to earlier on, reduces the cost of fabrication, and also cuts schedule. Designers and engineers work within a single context with focus on one task at any given time. This further reduces the loss of productivity due to the phenomenon of context switching and multitasking, again referred to by Jayne earlier on. Lean design and engineering is characterized by visible and reusable knowledge. In this example, a design issue encountered in the process of development in the detailed design phase is explored precisely and succinctly with great clarity of thought. Further, this design issue is rendered into a reusable form for future prevention of backtracking, perhaps on other projects as well. Trade-off curves are used as a way of quickly achieving optimal design. And you can see an example of trade-off curves on the right to the top. Here, the engineering of an injection quill with a suitable material of construction is explored for trade-offs, and suitable countermeasures are developed in lieu of an over-engineered and costly option. Lean design is characterized by collaborative decision-making that is smooth and fast. How often have you grappled with pros and cons, merits and demerits, and advantages and disadvantages of myriad options? It can be confusing and convoluted, the whole process of decision-making. Large number of hours can be excessively consumed in arriving at a final choice from a set of alternatives. Can we just focus on advantages alone? This method presented here is called choosing by advantages. Multiple disciplines and parties, such as the water treatment vendor, package engineer, the piping design engineer, stress metallurgy, and even client, work collaboratively to evaluate advantages and quantify the value of such advantages. The final choice is one that has relative advantage over the other alternatives at a cost differential that is justifiable. On the enigmatic topic of the involvement of trade foremen in developing a master schedule, a paradigm shift we mentioned within the last planner system, we invite you to consider two alternatives. In the first alternative, a master schedule is developed by a construction manager or general contractor with little inputs from trade partners. What level of confidence does this give the client? The second alternative, trade foremen make reliable commitments based on rich discussion with designers. These network of commitments are made working backwards from a milestone in a lean process called phase full planning. Further, the trade foremen are intimately involved in identifying and removing constraints on a 6-week look-ahead plan. What level of confidence does this give the clients, you think? The path to publishing an issued for review baseline 1 schedule on a FLUOR project is shown in the picture. Along the path are multiple workshops for phase planning involving trade foremen and activities to identify and remove constraints. Constraints are visually managed, and the entire team meets daily for 15 minutes to collaboratively remove them. The constraints within the next 3 weeks of construction activity can be seen sinking below a red line on the visual management board, shown in this picture, calling for urgent action. Anything underneath that line, the red line, is the focus of attention of anybody who's walking past the board. Lean execution comprising both design and build is enabled powerfully by integrated project delivery, which I introduced earlier on. Here we see FLUOR in the role of a construction manager working collaboratively with the client, the architecting engineer, and 2 builders to develop the multi-party agreement, which involved mutually agreed goals and shared rewards. This is one among a set of highly successful projects using this form of contract. This particular project was both ahead of schedule and under cost. The elements of a multi-party agreement shown in the bubble in the center is developed by all parties working together on a validation effort of a pre-feed or feed. All parties work collaboratively to cost, estimate, schedule, and develop plans as illustrated here, which informs the multi-party contract. The enabling category or aspect called IPD is also characterized by a joint project management team. The PMT collaborates in a mission control center, often referred to as a big room. The big room has its genesis in the operations of car manufacturer Toyota and is literally translated from the Japanese word obeya. The big room supports transparency and focus on the vital few gaps between goals and actual performance during execution. The big room that you see in the picture has many items, such as a currently active list of risks, opportunities, tied to pieces of execution on the wall. The big room is also co-developed by all parties, so its functional architecture has full buy-in of all parties. The big room is the vehicle for both collaboration and integration. Why should you believe Lean will work? I would like to hand over to Jayne for some good reasons why we think Lean works.
Thank you, Anand. Why do we think that the three aspects of the paradigm shift can make a difference to capital projects? Within FLUOR, the use of such methods have produced remarkable results. A scan of the results produced from the application of Lean methods on FLUOR projects over the last 3 years demonstrates the efficacy of the methods. However, what if we were to execute these methods holistically, supported by the last category of integrated project delivery? Would we have better project outcomes? Is there evidence to suggest that we can do much better? On a sampling of projects using Lean and FLUOR, we present evidence from 5 highly successful projects of the efficacy of using Lean methods in combination with a multi-party contract. All projects were ahead on schedule and within cost, and the projects were described by the project management team members as being very professionally fulfilling and satisfying. Several Lean methods were applied, testifying to the fact that the combination of methods works to change project outcomes. According to the Lean Construction Institute, like any good operating system, Lean is intended to be applied holistically to obtain maximum value. All of the key players need to be engaged and all of the major components and approaches applied fully. This framework suggests the project phases at which TBD and LPS are introduced and applied. However, it should be noted that IPD is the enabling framework for successful execution of TBD and LPS. FLUOR's intention is to exceed the benchmark set by the commercial and infrastructure construction industries in the quest to add value to owners. FLUOR views Final Report 341 from CII as a good benchmark, but one that can be exceeded through commitment of the project leadership. FLUOR has developed an approach to holistically executing Lean, where Lean methods are gradually introduced at the right time in the project lifecycle. And FLUOR is learning from the deficiencies of existing application within the industry and correcting it by the assimilation of methods that have worked in other design and development industries. An example of this is the use of trade-off curves to assist in speedy design, or the execution of construction work using production principles in order to meet schedule. Anand, on to you with some final thoughts.
Thank you, Jayne. In summary, through all phases of a project, a holistic Lean approach is crucial in meeting owners' existing and emerging goals. The key aspects or categories are target value design, last planner system, and integrated project delivery. Each of these approaches systemically reframes the opportunity to improve performance on capital projects by focusing on the source of waste and the significant loss of design and engineering time. Consequently, the time saved is diverted to adding value to owners. We will leave you with some final thoughts on building Lean capability. Everybody on a project is intended to be a practitioner of Lean. Supervisors lead Lean. In attempting to develop Lean capabilities, at first, an infusion of skills from outside the organization may be necessary. Frontline designers, engineers, and craft workers learn these new ways of thinking and working, solidified through repetition and experience. In order to gain traction with Lean, a good practice is to have an internal team of Lean coaches and consultants who, through persistent coaching and mentoring, will enable the project to gain a critical mass of Lean skills. Another opportunity is to look for some of these coaching capabilities within our partners' organizations. That can also be helpful. So thank you for your time and interest today. I'll now turn the floor back to Sabrina for question and answers.
Thank you, Jayne and Anand. So now that we've reached the end of the presentation, let's take a moment to address questions that we've received from the audience. And again, to our audience, please make use of the Q&A tab to enter any questions, and please send it to all panelists. So our first question, you mentioned target value design and described the characteristics of a few methods. Is there any one lean tool that you would consider the most valuable in design?
I can take that question, Jayne.
Go ahead.
Yeah, I would like to first start by saying target value design is a holistic system with multiple elements, and they should all be deployed in unison for maximum benefit. And this point was made earlier by Jayne on one of her slides. However, if you ask me to choose a very seminal method, I would say it's visible and reusable knowledge, and especially using trade-off curves. So if, Shruti, if you could go to that slide where we had, yeah, absolutely, this is a slide. So this type of visible and reusable knowledge is not merely reference material, but a way of thinking. This knowledge is intended to be captured on a single sheet of paper, which makes it very succinct. It's also meant to be communicated with great simplicity. If you look at the item number 5, the trade-off curves, it's easy to pick a point on the curve that's optimal with minimum chance of backtracking later on. So this is an example where this trade-off curves depict the relationship between failure of an injection quill and flow rate, angle of quill, and material of construction. What are the benefits of this type of visible and reusable knowledge? They can reduce design changes and RFIs. You can steer design to meet cost targets. You also can create a knowledge base for future use by owners and engineers alike. It can improve constructability. They can be the basis for improving the plant performance, faster decisions in pre-feed and feed, and better quality of solutions. What can they address? In our world, some things that come to my mind, it's fastening, vibration, stress, tank pressures, bending moment, compressive forces. Some of these, so on and so forth, for several potential input variables and materials of construction. I hope that served to answer the question.
Yeah, and I'll just add to that, Anand. So what I really like about these methods is that it gets people out of their silos and thinking about their own discipline. They can start looking at other factors that affect the project and affect the outcome of the project. And it provides a nice structure for multidiscipline collaboration. So it's not just left up to each individual to kind of like decide who they're going to collaborate with, but it kind of forces everybody to come together and then have a process to go through. So, and the whole idea here is to prevent backtracking in later phases of the project. So I think there's a lot of potential with this method, and definitely it could be a game changer.
Absolutely, Jayne. Very good point indeed. All of them are meant, most of these methods are intended to be cross-functional.
All right, thank you. So our next question, do you think a lean approach in design stage will help with the downstream stage, such as fabrication and especially construction? And is there any data available to support this?
Absolutely. I can take that question. Yes, we do have data, and we're quite happy to share the data with you. Definitely, it will prevent impact on construction. It will prevent what we call as backtracking, which Jayne alluded to a number of times in your detailed design phase. And very simply, it'll help you reduce, it'll help to make your schedule more predictable and certain.
Yeah, and I can just add there too that it's not just about, the design and engineering getting better. It's about the whole project.
Correct.
And there's a lot of players that have inputs into our designs, and we need to be better at making sure that the right people are involved in progressing the design at the right time. Sometimes this is client people, sometimes it's fabrication and construction. It just depends what we're working on. But all of these methods, when we talk about different silos, we mean anybody that's involved in progressing that design and making sure that it can be built successfully in the field.
Absolutely.
Thank you. All right, our next question. So it seems that FLUOR has experience being a partner in an IPD contract. What were the key learnings for you to make future IPD projects successful?
I can take that one on.
Excellent. Go ahead.
And you're welcome to chime in, but a few things that we've learned to date. So it's very important for the project management team to understand that, behavior changes don't happen overnight. And also that we need to manage expectations in relation to collaboration, integration, and then the effort that it takes to finalize a multi-party agreement as well. Project leadership needs to dedicate enough time and resources to onboard every team member to make sure that they understand their role in the new way of working. And we have to be careful in identifying our vendor partners. They need to be willing to engage in this type of framework and willing and open to work differently with us. Certainly implementing lean tools and methods, which fosters the collaboration that we've been talking about, things like big room, co-location, pull planning, last planner system. All that's very important. And, when problems arise, which they always will, the culture is more about solving the issue and progressing it rather than who is to blame. So anything to add there, Anand?
Yeah, the other thing from some of the projects that FLUOR have signed a number of such multi-party agreements and have got some rich experience. One thing that really struck me as very valuable is that transparency is not an option. Project leadership must assertively create transparency with the whole team, the project management team. So I think that is important. That actually I learned from one of our own project directors who worked on some of these multi-party agreements.
Absolutely.
IPD, yeah.
Thank you. So in reference to the slide on the paradigm shift, you said that doers plan within the last planning system. Can you please clarify how trade foremen contribute to building a master schedule?
I can take that, Jayne.
Okay, go ahead.
Typically, first of all, there is the part where you scope the construction area, a work area. Trade foremen who are part of that construction work area collaborate in the development of what we call the phase pull plan. Their commitments and durations are input into a master schedule by the superintendent and planner from the GC or construction manager. The GC meaning to say general contractor. GCA or CM then issue a 6-week look ahead that is reliable because it came from the people, the last planners themselves. The idea is to keep key milestones immovable because that is something that people think will move, but it's not supposed to move because those are the client's expectations, whilst allowing the trades to exercise creativity in how they work to improve the flow to get to the milestone. So I just wanted to point out there are two things here. One is some of those milestones stay sacrosanct. And it's only the more detailed work or the activities and how those activities are resequenced and executed that makes a difference.
Thank you. Okay, another one. You mentioned the paradigm shift. How long does it take to adopt this process or methodology within a team?
So it's introduced. And again, some people think that there are all these elements and they all should be obviously it seems like a really big beast. But what happens is progressively, as the project starts up, all these lean methods kick in one at a time. So you're really doing it in small pieces. You're not really doing the whole thing at one time. So when you introduce these methods in a progressive, incremental fashion, there isn't that much of big effort. It kind of gently infuses itself into the system. And it's just kind of, it happens as the project progresses. I wouldn't like to call out a separate timeline for this. It just happens as you execute the project very seamlessly.
Right, but the idea is that people are learning these methods and they need coaching to some degree to learn them. And then after some repetition, they can carry on and work in that way themselves.
Correct. And it's no different from anything else our designers and engineers learn. Obviously everything we do has a learning element to it. And I wouldn't think that this is going to be rocket science for any of our designers and engineers.
Thank you. All right. Next, how do you suggest implementing a concept of mission control, where this concept is likely quite foreign to our clients?
Well, so Jayne, I can take that question.
Yeah, sure. Yeah.
So it's quite interesting. Mission control has two elements to it. One is the big room, the obeya, and it comes from, big room is a literal translation of obeya, which we referred earlier on in the presentation too. So if you look at how this big room is developed, you have, first of all, the development of the project vision, development of shared values, develop goals, conditions of satisfaction, develop the risk opportunity register. What usually happens is by involving the client from step one, all the way in this process, the clients almost straight away see the benefits that this is going to bring to the project, because there's so much of, if I may say, alignment that happens. And all of this then results, all of these artifacts, for example, the schedule, the risks, they go on the wall. So you can imagine a 20, the obeya as being a 20 by 10 feet room in which all of these artifacts are visually seen around the room. So I think the buying in the owner by having them be part of this process, absolutely, it's captivating, it's powerful, and it elicits buy-in that you want. So the moment they're into two steps of this process, I can guarantee they'll be loving it.
Yeah, and I think it's all very logical, like you mentioned, Anand. Like it's things that they want to see. It's
correct
information that they can walk by and see what's going on, and that's the idea. Correct. So it just gives a level of transparency that many people like. I mean, another thing we could do is show them some of these in action, or show them some examples just to kind of get used to the idea, and maybe show some examples of like, what would you put in here and what benefits you're going to get, that sort of thing, if they're just learning about it for the first time.
Absolutely, yeah. And
thank you both.
And it solidifies that one team or one project community, because the obeya really represents the one project community visually.
Thank you. Okay, our next question. So we already use advanced workface planning. So how does that translate to LPS, the last planner system?
Now that's a good one.
Yeah, I'll take that.
I think Anand, you better do this one. We've had a lot of discussion
Absolutely.
about it, though. This is a common question. Yeah.
So advanced workface planning has got a downstream component called advanced work packaging has a downstream component called workface planning, WFP. Now, WFP came from last planner system, which is very surprising. People don't know that. So it came from last planner system, which of course came from lean production. So in effect, those who are practicing work phase planning are already using some of the principles of lean. However, what usually happens and or I should say, what typically happens is when you're trying to derive one system, such as work phase planning, from another system like the last planner system, LPS, there is some lost in translation. So what we have done successfully on a project in FLUOR is we have reinstated some of those lost in translation elements back into work phase planning so that it's now more robust. So I'm happy we'll be delighted to share this information with you as to how we've reinstated some of those missing elements. And some of those missing elements are very detailed, such as how those trade foremen would use their tags. There's also some create tags and put them on the wall. So they're very detailed techniques which were, obviously went missing during this process somewhere along the way. But a really, really good question, a question that I have actually responded to on numerous occasions.
Yeah, I was going to say it's a really good question.
A little bit surprising to hear that too. So thank you. All right. Next, with regard to multi-party contracts, are there any learnings that you can share?
Oh, absolutely. So the multi-party contract is developed by all the parties. So initially, all parties are paid by the client, et cetera, et cetera. They paid both their cost and their fee, and they all get together and work on the multi-party contract. And in my opinion, it's going to be rough. It's not something that is smooth and easy. So we have to manage expectations that overnight people will be the perception that this is going to be easy should be managed. People should know it's going to be tough. There are certain pitfalls or certain areas where where the parties can have a bigger challenge. For example, in relation to insurance, in relation to tasks, which party will work on which tasks. So that can be quite a challenge. Insurance can be a challenge. Then I'm starting to think of some other areas where you can have a challenge. The expectations laid out in a multi-party agreement, such as the use of target value design, collaboration and integration methods, these things can also pose a challenge because not all parties will be familiar or experts in all of these collaboration and integration methods. So that negotiating what each of these parties will do and how they'll overcome each other's deficiencies is definitely challenging. But once that is done, you can expect everything to move forward smoothly.
All right. Thank you.
Hope I answered your question.
Very much so, I think. All right. And so in working with very large projects, how would you decrease the amount of context switching that happens in the execution process?
I almost think it's easier, Jane, if you don't mind, I'll take this question.
Yeah, go ahead.
It's easier to organize your task force into smaller teams based on subsystems and based upon more granular tasks than it is with smaller projects. So I think on a bigger project, reducing context switching is easier than on a smaller project. On a smaller project, you almost expect people to think that I can't split the team up. I can't split the task force. I can't organize them by sub-teams and clusters easily. But with a larger project, I think it's much easier.
Thank you. And then with regard to decision-making using CBA, you showed only two alternatives. Are there more decisions? And so how would you deduct to only 2 alternatives?
Yeah, on the
Jayne?
CBA, that was just kind of a small part of the CBA. So there's definitely more alternatives you can consider, more factors. Yeah, this is just for an example. It's actually, most decisions involve a lot more factors than what's shown on here, that's for sure. The magic of this decision making, though, is all about getting those right design partners or parties together to make this decision, and to have a nice structured way of getting through it. And in that way, it also provides a documentation to that decision. You don't have maybe one discipline or one party making a decision that really puts a lot of unneeded work to another discipline or to construction, for example, if you're able to bring in all the right people at the beginning to do that. So yeah, we just showed 2 alternatives there, but you can definitely have several alternatives. Did that answer the question?
Yes, it did. Thank you. And it looks like that's all the time we have for questions today. So thank you, Jayne and Anand, for this informative webinar and the time you've spent preparing for it. So thank you to our audience for attending. It's been a pleasure being your moderator. So please join us for our next webinar, which will be on June 23rd, where we'll have FLUOR Fellows Andre Fijan and Florin Omoda. We'll talk about successful layer of protection analysis study and follow-up. Please continue to stay informed of these events by visiting the Innovation Builders page on FLUOR.com or following our social media channels using hashtag Innovation Builders. If you'd like to receive email notifications of future webinars, please send us an email at innovation.builders@fluor.com with opt-in in the subject line. So we appreciate your attention. Thank you for dialing in today, and we'll send out a compiled list of the Q&As within a few days, along with a notification that the webinar recording is available for replay on fluor.com. So if you have any questions or require additional information, please email innovation.builders@fluor.com and someone from our team will get back to you. So thank you from all of us at the Innovation Builders team, and have a safe day.